This is the last shortcut to proving triangles congruent, and this is going to mainly involve right triangles. So we need to first talk about parts of a right triangle. And if we look at the long slanted line in the triangle, that's called the hypotenuse. The two sides that make up the 90-degree angle are called legs. And so today we're going to talk about a theorem called hypotenuse leg, and that's going to be a shortcut to proving two triangles are congruent. So this says that if you have a hypotenuse and leg of one triangle that's congruent to another hypotenuse and leg of another, then the two triangles are congruent. So in this case, if we called it triangle ABC, it would be congruent to triangle DEF. In order to use this, we need some criteria. So in the first case, you have a hypotenuse and a leg in a right triangle. You need congruent hypotenuses and you need one congruent side. That's the three criteria to use this condition. All right, so in example 1, find the mistake in the following statement. Triangle CPA is congruent to MPA. And if we look, we have one congruent side listed, we have a shared side in AP because it reflects a property, and we have an angle. So do we have a hypotenuse and a side? Yes, we do. And we can also say that this is congruent by side, 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 with something we'll learn later on. But we cannot prove this is true by side angle side, because side PC and side MP, we don't know enough about to prove it congruent. So the mistake in this problem is the side angle side. In this example, we want to see if we can prove it and if we can justify it. So we notice we have right triangles and we have two congruent hypotenuses. So in this case, if we have one congruent leg, then in fact we can prove this by hypotenuse leg. So if we write down the givens in the problem, because of the description, we have 90-degree angles and we have congruent hypotenuses by the marks. And we know side AP is congruent by the reflexive property. So this triangle would be congruent by hypotenuse leg. If we look closer, we can also prove this triangle is congruent using a different proof. Now this one is a little bit more complicated than what you're going to be required in class, but you can prove things congruent in more than one way. So this is one of the longer proofs we've had in class. So triangle XYZ is isosceles. Why do we know that's true? Because it's given in the statement. It says XY is congruent to XZ. Why would that be true? Because it's not given in the statement. That would be the definition of an isosceles triangle. Because they tell us the vertex is X, then that means that XY and XZ are the legs of the isosceles triangle, and so they would have to be congruent. XM is perpendicular to ZY. That is because it's given in the problem. Now, M wasn't initially listed in the diagram, so we're going to add it because in the actual congruency statement, it talks about a point M, and that would make the two triangles related to the congruency statement. So this case, XMY would be a right angle and XMZ would be a right angle, and that's what actually defines a perpendicular line. And the reason we say that is because perpendicular line is listed in the given statement. Then we have triangle XMY and triangle XMZ are right triangles. And the reason is they have a 90-degree angle, a right angle in them. XM is congruent to XM by the reflexive property. So in this case, now we have proven we have a hypotenuse that is congruent. That was statement 2. And we have a right triangle, which was statement 5. And now in 6, we have proven that the sides, the leg, is congruent. So we have proven the 3 criteria for hypotenuse leg. Okay, so in this case, MA is congruent to TH, and that is proven that that is justified because it's given. MT is congruent to MT because of the reflexive property. Then we talk about angle MHT and angle TAM are right angles, and we know that's true because it's given. Because we have a right angle, we therefore have right triangles, and that would be the definition of right triangle. So now we have a leg, which was in step 1. We have a hypotenuse, which was in statement 2, and then we just proved that we have right triangles, which is statement 4. And so this would be congruent by hypotenuse leg.